So, welcome back to the next video in my video series about Linux. In this video, we'll try to learn about the Linux operators. Stick with me if you want to learn more about this. Hello YouTube, what's up guys? Medium Guy over here. Just before I start the video, please go ahead and check the other videos in this video series. We tried to learn cool stuff about Linux, and in this video we'll try to learn about the Linux operators which we'll try to use in making conditions. So without any delay, let's get down to work. So generally we have 5 types of operators. First being arithmetic, second the relational operators, third the Boolean operators, fourth the string operators, and lastly fifth the file operators. So we'll start by the arithmetic operators and we'll see and learn one by one. So if I hit ls, I've got my previous files for the previous videos, which I'll put the repository link down below if you want to access them. Next, I'll try to create a file. I'll say nano ar-op.sh. In the first line, as always, I'll address the /bin/bash. And next, I'll try to declare some variables and use the arithmetic operators. So I'll say name equals to xpr2 plus 2, and I'll say echo value is $name. So if I hit save, as always, I'll say chmod plus x ar-op. I'll say /ar-op, and as the result I can see I get the value is 4 because 2 plus 2 equals to 4 if you didn't know. So if I go back to the bash script, just pay attention to the back tilt sign. So basically it allows us to run other commands in the exact same line of the command that we are writing. So basically the result of this will be stored in the variable that is called the name. So of course we have other arithmetic operators. So as we saw, we have the plus. Next I want to show you guys the other ones. So I'm just gonna fast forward this part. So as you can see, I've tried to test out the other arithmetic operators. So if I try to run it, so as we can see, the plus operator has summed up the 2 plus 2, the minus has also worked correctly, the division also worked correctly, and there seems to be some syntax error in the 2 multiplied by 2. So if I nano the bash script, so I found that the star, as we know, can have some other meanings. So if I put a backslash right before the star, it will try to do exactly what I want it to. So it'll try to multiply 2 by 2. If I run it, I can see that I get the 4 for the 2 multiplied by 2. So next up, let's try out the other arithmetic operators. So we have the percent sign. If I run it, I'll see that I get the 0 as the result of it. So basically what the percentage operator do will try to divide the 2 by 2, and it will try to return the remainder of the division's result. So next up we have 2 more operators, which is equal to, which compares if the first is equal to the second, and also we have the not equal to. If I hit save, I'll run it, you'll see that I get 1, which stands for true for the 2 is equal to 2, and I got 0 for the result of 2 is not equal to 2, and basically 0 stands for false. So next up we have the relational operators. So I'll try to nano rel-op .sh. As always, I'll address the /bin/bash. So I'll say $a is equal to string 10 and $b is equal to string 20. I'll try to create a if statement. If you have problems with if statements, I'll recommend you go watch my previous video. I'll put the link down below. So I'll say if brackets $a eq $b, then I'll echo true, else I'll echo false, and I'll say phi to end the if statement. So I'll save the file. I'll say chmod plus x to the rel-up. I'll say /rel-up. So I got some errors saying command not found. If I try to nano mistakenly, I provided dollar when declaring the variables. So as we know, when declaring variables, we shouldn't put dollars before their names. So if I save it, again, I'll try to run it. As I expect, it returns false because their value is not equal. So next up, we have the not equal operator. So I'll just copy the previous if statement, and in here, I'll say NE standing for the not equal. If I run the script file, I'll get the true for the second if statement. Next, we have the greater than operator. I'll say GT. Also, we have the less than operator. I'll say LT. If I run it, I'll get false because A is not greater than B, but it is less than B. And next up, we have the greater than equal operator, which is exactly the same, but it has an E at the end of it. So basically it is greater or equal to B. So basically it returns true if A is greater or equal to B. Also we have the less than equal. So I'll say ALEB. If I run it, again I get false, but for the second, because it is less than that, I get true. So next up we have the Boolean operators. So I'll say nano bool dash up dot sh. I'll address the /bin/bash. We have the not operator. So if I, for example, say if not false, closing the brackets, then echo true phi to end the if statement, and the not operator will return true if the expression's result is false. And also if the expression's result is true, it will return false. So basically it tries to reverse the result of the condition. If I run this, I expect to see the true as the result for the bash script. So I say chmod plus x bool-op.sh, and if I say bool-op.sh, I don't get any result. The thing that is mistaken is that there should be no space between the not operator and the expression itself. So if I save it, if I try to run it, I get true as the result. So next up we have the -o, which stands for logical OR, and we have the -a, which stands for logical AND. So if I edit the file, I'll say A is equal to 10, B is equal to 20, and in here I say if $a $lt $b $o $b $gt 100. So basically what is being checked in here is that if $a is less than $b, or if the $b is greater than 100, the result of this if statement will be true, and we'll get the true as the result of this bash script. So if I save it, I'll try to run it, and I'll get the true as the result because $a is less than $b. So we have the -a operator. If I change the -o to -a, it will check if the both conditions are met, and if they are, it will return true. So I'll save it and I'll run it. I get only one true because the second if statement did not return true, and so it won't echo true. Next up we have the string operators, so I'll say str-op.sh. I'll address the /bin/bash. So I'll say if $a equal to $b, echo true. So again, we have the equal sign to compare the values of $a and $b. If I save it, I'll say chmod plus x str-up. I'll say /str-up. So because their values are not equal, it won't return true as the result. Also, we have the not equals operator. If I run it, I see I get one true. We have the -z operator. So $z$a. So basically what it does is that it checks that the $a's size is equal to 0 or not. If it is, it'll return true. And exactly like this one, we have the -n, which checks if the size of the $a is not 0. So I'll say 0 in here, and I'll say not 0. So if I run it, I'll see that it is not 0. So basically it has some value in it and its size cannot be 0. So that's it for the string operators. And next and the last, we have the files operators. So I'll try to nano file-up.sh. I'll address the /bin/bash over here, and I'll say f equals to one of the file names that I have in here. Like for example, I'll copy this. Again, I'll nano and I'll paste over here. So I'll say if -f $f echo $f is a file. I'll say phi to end the if statement, and as you have might guess, the -f operator will check if the given value is a file or not. So I'll save it. I'll say chmod plus x file up-sh. I'll say file up.sh. So as it returns, it says that the rel-up.sh is a file. So again, I'll nano it. We have exactly the same, but the -d, which checks if the given value is a directory. So I'll change the file to dir. I'll save it, and if I run it, I see that the if statement which checks the given value is a directory will return false. So again, I'll try to nano it. We have the -r, which checks if the given value is readable. So I'll say f is readable. Also, we have -w, which checks if the file is writable, and we have the -x, which checks if the file is executable. So if I hit save, I'll try to run it, and as I can see, the given file is readable, writable, and executable. So again, I'll try to nano it. We have the -s operator, which checks if the given file size is more than 0, it returns true, and if not, it returns false. So I'll say $f size is greater than 0. And also we have the -e operator, which checks if the given file already exists. So I'll say $f exists. So if I save it, I'll try to run it, and as I can see, its size is greater than 0 and it also exists. So if I try to change the given file, so for example, if I add another h at the end of it, I'll save it, I'll try to run it, and I can see that it's not a file, it's not readable, writable, executable, its size is not greater than 0, and it doesn't even exist, and because of that none of the conditions return true and I didn't get any echoes. So that's all for the operators in Linux. I hope you get the idea about this. If you have any questions, just go ahead and ask me in the comment section down below. I'll be glad to help if I can. Also, don't forget to watch my other videos that I have on my channel, and also don't forget to like and subscribe. And with that, I hope to see you in the next video.